What do you think of when you hear the word robot? Is it a futuristic machine that can do almost anything? Or perhaps a simple device that helps with everyday tasks? Some might imagine a metallic humanoid from a sci-fi movie with glowing eyes and a mechanical voice, while others might think of a machine arm assembling cars in a factory, tirelessly working to put together the vehicles we drive every day. Both are robots, but what exactly makes them different from, say, a toaster? A toaster is a simple machine, but a robot is something more. A robot is a special kind of machine. It's not just about doing a task, it's about doing it automatically and intelligently. It's not just about doing a task, it's about doing it automatically. Robots can perform tasks without human intervention, making them incredibly useful in various fields. Think of a toaster. You put in bread, press a button, and it makes toast. It's a straightforward process. But it always does the same thing. It doesn't adapt or change based on its environment. A robot, on the other hand, can sense its surroundings, make decisions, and then take action. This adaptability is what sets robots apart from other machines. This ability to sense, think, and act is what makes robots so unique. They can process information from their environment and respond accordingly. They are like little helpers that can do things on their own without us needing to tell them every single step. Imagine having a helper that can clean your house, cook your meals, or even assist in medical surgeries. This is why robots are becoming more and more common in our world, doing all sorts of jobs for us. From manufacturing to healthcare, robots are making our lives easier and more efficient. But how do robots actually work? What makes them capable of performing such complex tasks? How do they sense what's going on around them? Robots are equipped with various sensors that allow them to perceive their environment. These sensors can detect light, sound, temperature, and even touch. How do they think about what to do? Robots have processors and software that enable them to analyze the data from their sensors and make decisions based on that information. And how do they actually act on their decisions? Once a robot has made a decision, it can execute actions through its motors and actuators, allowing it to move and interact with the world around it. Let's dive in and find out. We'll explore the fascinating world of robotics, uncovering the technology and innovation that make these incredible machines possible. Imagine you're walking through a park. You see the lush green trees, smell the fragrant flowers, and hear the chirping birds. You use your senses, sight, smell, hearing, to understand your surroundings. Robots have senses too, but they're a little different from ours. Instead of eyes, robots might have cameras that capture images. These images are then processed by the robot's brain to understand its environment. To sense objects in the dark or measure distances, robots use LiDAR, which is like a radar that uses lasers. Ever wondered how your phone knows which way is up when you're playing a game? It uses a sensor called a gyroscope. Robots use these too, to keep their balance and move smoothly. They also have sensors for touch, temperature, and even smell. All these sensors allow robots to gather information about their surroundings. It's like giving them superpowers to see, hear, and touch the world in their own special way. Now imagine you see a ball rolling towards you in the park. Your brain quickly processes this information. A ball is coming. I should probably move out of the way. Robots need brains too to make sense of the information gathered by their senses. But robots don't have brains like ours. Instead, they have computers or microcontrollers. These are like tiny electronic brains that process information and make decisions. They take the data from all the sensors and use it to figure out what's happening around them. Think of it like this. The sensors are like the robot's eyes, ears, and nose, and the computer is like its brain, putting all the information together. Based on this information, the robot's brain can then tell it what to do. But how does the robot actually think? That's where things get even more interesting. So, the robot has sensed its environment. It uses a variety of sensors to gather information about its surroundings. These sensors can include cameras, ultrasonic sensors, infrared sensors, and even LiDAR. Each type of sensor provides different data, helping the robot build a comprehensive understanding of the world around it. And its brain has processed the information. The robot's brain, or Central Processing Unit, CPU, takes all the data from the sensors and makes sense of it. This involves complex algorithms and computations to interpret the data accurately. The CPU decides what actions the robot should take based on this processed information. Now what? It's time for the robot to act. The decision-making process is complete and the robot is ready to execute its next move. This is where the real magic happens, as the robot transitions from thinking to doing. This is where actuators come in. Actuators are the components that convert the robot's decisions into physical actions. They are the bridge between the robot's brain and its body, enabling it to interact with the physical world. Actuators are like the muscles of a robot, providing the necessary force and movement. Just as muscles contract and relax to move our limbs, actuators extend and retract to move the robot's parts, allowing them to move and interact with the world. Whether it's picking up objects, navigating through a room, or performing complex tasks, actuators are essential for any robotic action. The most common actuators are motors. Motors come in various types, including electric, stepper, and servo motors, each suited for different applications. Just like the motor in your toy car, these motors help robots move their wheels, arms, and other parts. They provide the rotational force needed for movement. These motors help robots move their wheels, arms, and any other moving part. Motors are versatile and can be used in various configurations to achieve different types of movement. Some robots use hydraulics or pneumatics, which use liquids or air pressure to create movement. These systems are often used in applications requiring significant force or precise control, or air pressure to create movement. Hydraulics and pneumatics are powerful and can be used for tasks that require lifting heavy objects or performing delicate operations with great precision. Think of how a hydraulic jack lifts a car. It's the same principle. The hydraulic fluid is pressurized, creating a force that lifts the car. Similarly, robots use hydraulic systems to achieve powerful and controlled movements. These actuators are controlled by the robot's brain, which sends signals telling them what to do. The brain uses a combination of software and hardware to send precise instructions to each actuator, which sends signals telling them what to do. These signals are like the nervous system in humans, transmitting commands from the brain to the muscles. Want the robot to move forward? The brain tells the wheel motors to turn. This simple command sets off a chain reaction, resulting in the robot moving in the desired direction. The brain tells the wheel motors to turn. The motors then convert electrical energy into mechanical energy, causing the wheels to rotate and propel the robot forward. Need to pick up an object? The brain instructs the arm to extend. This involves coordinating multiple actuators to achieve the desired movement. The brain instructs the arm to extend and the gripper to close. The arm's actuators work in harmony to reach out, while the gripper's actuators ensure a firm grasp on the object, and the gripper to close. This precise coordination allows the robot to handle objects with care and accuracy. From simple movements like turning a wheel to complex actions like playing a musical instrument, actuators are what bring robots to life. They enable robots to perform a wide range of tasks, from the mundane to the extraordinary. To complex actions like playing a musical instrument, actuators are what bring robots to life. They are the unsung heroes behind every robotic action, making it possible for robots to interact with the world in meaningful ways. Actuators are what bring robots to life. Without them, robots would be nothing more than static machines. It's the actuators that give robots their dynamic capabilities, allowing them to move, interact, and perform tasks with precision and efficiency. Section 5. Working together, the robot feedback loop. We've talked about how robots sense, think, and act. These three components are fundamental to their operation. But here's the really cool part. These actions aren't just one-time things. They are part of a dynamic process. Robots are constantly sensing, thinking, and acting in a continuous loop called the feedback loop. This loop is essential for their functionality. Think about picking up a glass of water. It's a simple task for us, but it involves a complex series of actions and feedback. You use your eyes to see the glass, gauging its position and orientation. Your brain processes this visual information to judge the distance and weight of the glass. Then your muscles coordinate to move your hand towards the glass, but you're also constantly getting feedback from your senses. Is the glass slippery? How heavy is it? Is it cold or warm? You adjust your grip and movement accordingly, ensuring you don't drop it or spill the water. Robots work the same way. They are equipped with various sensors to gather information about their environment. They take in information from their sensors, process it using their onboard computers, and then act based on that processed information. This action could be anything from moving an arm to picking up an object, but then they use their sensors again to see how their actions change the environment. This is crucial for making adjustments. This feedback allows them to adjust their actions in real time, making them adaptable and responsive to new information. This adaptability is what makes robots so effective in dynamic environments where conditions can change rapidly. This feedback loop is what makes robots truly smart. It's not just about following pre-programmed instructions, but about learning and adapting. It's like they're constantly learning and adapting to their surroundings, just like we do. This continuous learning process is what sets advanced robots apart from simpler machines. Robots were once confined to the factory floor, performing repetitive tasks with precision. But now, they are entering our homes, transforming the way we live. From robotic vacuum cleaners to smart home assistants, these machines are becoming a part of our daily routines. It's fascinating to see how far we've come, isn't it? Artificial intelligence is revolutionizing the robotics industry. With advanced algorithms, robots can now learn from their environments and adapt to new situations. This means they can perform more complex tasks, from diagnosing medical conditions to driving cars. The integration of AI is truly changing the game, making robots smarter and more efficient than ever before. The rise of robots and AI brings up important questions about jobs and ethics. Will robots replace human workers? How do we ensure that these technologies are used responsibly? It's crucial to have these discussions as we move forward. The future of work and society depends on how we address these challenges. We are living in exciting times where the possibilities seem endless. The advancements in robotics and AI hold the promise of a brighter future, filled with innovation and new opportunities. As we continue to explore and develop these technologies, one thing is certain: the journey ahead will be nothing short of extraordinary.